So in this example, we're looking at very similar things to what we looked at in the first example. Instead of test scores this time, we're talking about high school basketball shooters' shooting percentages. Near the end of the game, score is tied, best shooter has fouled out, and the coach needs to make a sub. So the coach is looking at data for this and wants to make the best choice for the sub that he can. So we can just look at each individual shooter's performance over the last 10 games. We can see some patterns. Morgan has had a couple of bad games. She had a 19% game and a 21% game, but she also had a really good game with 48% shooting. So maybe Morgan's on a hot streak tonight and it makes sense to substitute her in. Or maybe she's on a cold streak and it doesn't. Looking at, let's say, Patrice, Patrice had never had a game below 34%. So Patrice has never had the low games that Morgan has, but she's also never had the high games. Maybe Patrice is doing what she usually does tonight, and that's okay as well. But the easiest way to do this, if we're looking at the data, is to look at each shooter's mean score, their average, as well as their standard deviation as well. Because a high mean score with a large standard deviation would mean that they're a good shooter, but they also have a lot of spread. They have really good games, they have really bad games. A low mean with a low standard deviation would mean they're not quite as good of a shooter, but they shoot about the same all the time. So again, we'll go to the graphing calculator to do this. I'm going to go a little bit faster this time than with example one because we are doing essentially the same thing. As well, as always, if you need to pause to catch up to where I am, please pause the video and catch up as you need to. So we'll go and enter the data. We press Stat, Edit. I'm going to enter the data for Anna. It helps if you push the right buttons. Quit out of there, second mode. Going back to Stat. Over to Calculate this time. Option 1, enter to do the calculation. So we see, I'll set this up as a table. We have Anna, Patrice, Morgan, Paige, and Star. And as I said, we're going to look at the mean as well as their standard deviation. So Anna's mean, 36.7%, and her standard deviation, we'll just go one decimal place this time, 5.9. We'll clear that out, go back, and we'll enter the data for Patrice. Again, clear out Anna's data, clear, enter to do the whole list. And again, I am hitting the wrong buttons. If you find a mistake before you actually get out of a line, you can just press clear and get rid of the whole thing. Quit out, Stat, Calculate, option 1. And Patrice has a mean of 36.4, standard deviation of only 1.5. So on average, slightly, very slightly less, but also much less spread than Anna. Going to Morgan. Quitting out. Going to Calculate, option 1. Morgan's mean, 35.8% with a 9.0 standard deviation. Paige, and I know I've said this at least once already, if you need to pause to catch up to me, please pause. but by now we're just going through the same process 5 times for 5 different people. So I am going to speed that up as I've been doing. Paige's mean 33.9%, standard deviation of 0.8. And last but not least, we'll do star. Mean of 36.3, standard deviation of 3.3. So in terms of who's the best shooter, by average alone, it would be Anna. But Patrice is very close behind, and she also has a smaller standard deviation, so she's a more consistent shooter. Paige is the worst shooter on the team by average, but also the smallest standard deviation. So if you're the coach and you're looking at data, and you just want your best shooter on the team no matter what, Anna's your choice. If you want someone who is almost exactly as good, but more consistent, Patrice is almost exactly as good and significantly more consistent. Starla is essentially the same as Patrice, only 0.1% less, but a slightly bigger standard deviation. Morgan has the widest standard deviation of anybody, which would be expected because she had those games of 19 and 21%, as well as the game of 48%. So she has a wide spread in her data, which means the standard deviation will be bigger. But if you're the coach, that's your decision. If I was the coach, I'd pick Patrice to take the last shot, but that's my decision.